Welcome everyone. In this video, we are going to discuss about Prometheus and Grafana and also the project that I have created using these two frameworks. So to understand what Prometheus and Grafana are and how they are used, I have this diagram created. So let's just imagine that we have three data sources. So data sources in this scenario could just be an HPC node, it could be a MySQL server. Let's say we have two data sources. One is a node in an HPC cluster, and that node has NVIDIA GPUs in it. And another node is a MySQL server which acts as a database. Now the thing is, in this video I'll be using the terms logs and metrics interchangeably. So now the node with the NVIDIA GPU will produce certain kinds of metrics, and the MySQL database will produce certain kinds of metrics. Now, to aggregate all of those metrics or logs, we use Prometheus. So Prometheus is responsible for pulling or scraping logs or metrics from various data sources. So Prometheus cannot do it alone. It also needs the help of nodes or endpoints known as exporters. So for an HPC node, to get GPU metrics like utilization, CPU utilization, the VRAM utilization, the temperatures. So the NVIDIA GPUs have a dedicated exporter known as a DCGM exporter. So Prometheus interfaces with the DCGM exporters. It gets in all the logs, and Prometheus also has a query engine built in. Why does it have a query engine? We'll discuss it further. So now that we have all our logs in a centralized store, let's say a database, now we need to make some visualizations or dashboards based on that, because that's the entire point of observability. You can't really go through the logs yourself and make sense out of it unless it is put up in a graphical format. So what Grafana is, it's basically a visualization layer which queries data that is stored in Prometheus using PromQL. So PromQL is a modified version of SQL just for Prometheus. So Prometheus has the data and Grafana queries that data, and it gives that queried data back to the user in form of dashboards and charts that are easy to read. Now in this diagram we also have alert manager. So we have lots of logs, lots of metrics and events stored in Prometheus. So let's say if you want an alert if your GPU utilization or the GPU temperature is more than 85 degrees Celsius for like 30 minutes, you can get customized alert to your mobile phone, to your email ID using the alert manager service. So now let's see how I have implemented Prometheus and Grafana on my local system using WSL2. If you want to scale up to an HPC cluster, the logic is the same, just that the number of nodes will increase significantly. So here is the repository that we will be following. If you go ahead and clone my repository, you can run the setup.sh bash file. So what it would do is it would spin up some nodes and it will give you a template so that you can get your Grafana and Prometheus setup. So if you run that script, what would end up happening is that you would have 6 nodes in total. The 3 are the HPC nodes. These are not actually the HPC nodes. These are just the Docker containers which are simulating the network traffic of an HPC node. So we have 3 nodes or 3 data sources, and we have one node exporter. Now, typically in an environment, in an HPC environment, we don't need a separate node exporter because DCGM exporter already does this task for us. So since we are not in such environment, we need another node which is node exporter, Prometheus, which gathers all the information, scrapes all the information, and Grafana, which queries all the information and gives us dashboards and visualizations on top of that. Now first Prometheus has scraped all the targets. Here as you can see, it has recognized that all the states of the nodes are up, and now the logs can be scraped from these instances. Now that we have all the information, what Grafana can basically do is it go and query all the information and give us visualizations on top of that. As you can see, we are able to take a look at the network traffic, packets transmitted per node, packets received per node, number of open files, host CPU utilization. The CPU utilization is flatlined because we aren't performing any activities in those nodes. Then the memory utilization, disk utilization, all of these screenshots are from when I was running the actual demonstration. I'm not doing it live because running a lot of commands takes up a lot of time. So I've already done all the setup for Prometheus and Grafana, and I have documented everything. You can definitely go to the GitHub repo. This was just an explainer video which is supposed to supplement the resources. And now if you want to extend this project, if you want to extend this deployment to our actual HPC cluster, what you need to do is that you just deploy node exporter as a service on each compute node instead of having a separate node, and you will be able to get metrics and their visualization from your entire HPC cluster. And that was it for this video.